All right. So, here we go. Practice test number 2. Remember that because I have to give different versions of the test, your test may not look exactly like this, but these exact problems will be there, just in different orders, right? So we're not going to be alarmed if your word problems come first, okay? All the problems on the practice test are on the test, just maybe mixed up a little bit in order. Okay, so we got our note cards out, we got our calculators out, and we are ready to, we're on number 2. We're doing practice test number 2. Tell me about this first problem. 19 over x to the 4th. Remember, we're not going to be tricked by the negative exponent. Negative exponents move, right? But only the thing with the negative exponent moves. So that's coming to the bottom, just the x to the 4th. Got it? We took a quiz and some of you missed this. Don't miss it on the test. All right, what about this one? Sean Oldham, what would you like to do to get this problem started? Inside, okay? Remember your options are simplify inside, like Sean likes to do. I like to do that too. Or cube everything and then simplify. We're going to simplify in here. So, obviously 2 and 3 don't simplify, so they stay. Now, you got 7 x's over 2 x's. They're going to cancel each other out. Who has more? The top. How many more? 5. So we have x to the 5th on the top. Now, look at your y's. Do not do the same thing with your y's. When it's a negative, it has to move, right? So this is like having 4 people upstairs and 11 more come upstairs. Now what have you got? 15 people upstairs. And now we're going to cube the whole shebang. We took care of our x's and our y's, and now we're going to cube it. 2 to the 3rd. 8. Over 27, okay. 3 cubed, 27. Now, what do we do when we got a double exponent? X to the 5th to the 3rd. We multiply. So x to the 15th, y to the 45. Anybody have an issue with that? All good. Okay. C, 5/8 to the negative 2nd. What does that negative do? Flips it. So we're going to have 8/5 to the 2nd. 8 squared, 64. 5 squared, 25. 64 25ths. So far, so good. 1/8 to the negative 2/3. Now be careful. See that negative right there? What's that going to do? Flip this fraction, right? So instead of 1/8, we're going to have 8 over 1, or just 8. Now, what does a fractional exponent mean? Radical. So we're going to have a radical. And because the denominator is a 3, it's going to be a cube root radical? Yes. So it's going to be the cube root of 8, and then we're going to have to square. This tells us to cube root. This tells us to square. So what's the cube root of 8? 2. Cube root of 8 is 2. Kids, what times what gives you 8? 2, right? 2 cubed is 8. So the cube root of 8 is 2. But we have to square that, so the answer is 4. The cube root of 8 means what times itself gives you 8? That's what it means to be a cube root. And then finally, 144 over 25 to the 1/2. Well, there's no negatives here, so don't be flipping anything, but you got a fraction, right? What a fraction means is a radical. Yes, Mikey, you're right, because this is a square root radical, and a square root of 144 is 12, and the square root of 25 is 5. So somewhere on your test, you're going to have a group of exponent problems to simplify. Everybody okay with that section? Okay. Now, then you're going to have a couple sequences here. Let's see. And you got to fill in the blanks and then figure out if it's if it's geometric or not. Okay? So, let's see if we can fill in these blanks here. Can you tell what's going on? What seems to be happening here?
-2.
We're multiplying by -2. These take a minute sometimes. Spend some time figuring out, how am I getting from term to term? I'm multiplying by -2. So, this would be -32 and 64. And then going backwards, what would this be? 1 and -1/2. Very good. Is this geometric? Yes, this is geometric. Why is it geometric? Because you're getting from term to term by multiplying by the same number. That number is your common ratio. All right, now, this one, let's see, I only have these terms right here. What does it look like's going on there? What am I doing? So I'm adding -2 or subtracting 2, however you want to think about it. So I go from -1 to -3 to -5, so this would be -7 and -9. And then what would happen going the other way? +2. So this would be 1 and 3 and then the 5. So we got a pattern here. We're adding -2. Does that make it geometric? No. Liam, you with me? Not geometric, because I'm not multiplying, I am adding or subtracting. Alrighty. Alright, so now I've got a little exponential equation. And I'm going to answer some questions about it. We did this last time we were together. Anybody remember anything about the horizontal asymptote, the y-intercept, or increasing, decreasing? Mamuna.
The y-intercept, just plug in 0.
Exactly. So the y-intercept, I got to plug in 0 for x. That's how you find the y-intercept in every equation anywhere in the whole wide world. We plug in 0 for x. So what happens if we put in 0 for x? This becomes 1 times 4 minus 1, 3. Now, honestly, you should be able to do that without a calculator, but you got a calculator. If you can't do it, type it in the calculator. Okay, what's the other one you said you knew, Mama?
It's decreasing.
She says this is decreasing, and she is exactly right. And how did you know that, Mamuna? By looking at the problem.
The number in parentheses is less than 1.
The number hooked to the x, the one that has the power, is less than 1. If the number that has the power, has the x, is less than 1, then you're decreasing. If it's bigger than 1, then it would be increasing. us anything about the asymptote? Anthony? Y equals -1, you're exactly right. And that's because, guys, every exponential, every time x is the exponent, the asymptote starts out at 0. If you do something to move it up or down, then you're going to move that asymptote. This time we subtracted 1, which is going to drop it down 1 unit. So far, so good, folks. We're feeling like we can manage. Hopefully. We got one more day to practice. 3, 6, 12, 24. Got a little sequence here. What's the common ratio? 2. What do we mean by common ratio? What are we talking about? The number that we multiply by to get from term to term. This is a geometric sequence, and the ratio is 2. How do we find the 8th term? Well, you got a note card, but you probably can do this one without your note card. What do we start with? The first term, which is 3. And we multiply it by the ratio to the 1 less power. That's exactly right. So on your paper, you have this formula, which is the formula that finds the nth term of a geometric sequence. Let me take out a calculator, and I hope that you are all going to be sitting there typing in with me, because I promise on test day I am not going to type in the answers and put them on the board. You need to be able to do that. I got 384. Is that what you got? All right, good. S sub 10. Well, big S is a clue. You got a formula for that. So the formula says first term minus first term times ratio to the 10th over 1 minus the ratio. I just copied that straight off my note card. Always do the denominator separately, please. In this case, it turns out just to be -1. Then you can go ahead and type in your numerator, 3 minus 3 times 2 to the 10th. And it works out to be -3069, if I did it right. So the answer is just 3069. Any question about that? All right, now we just have some equations to solve. So 2 log 5 minus 8 equals x. Now wait a second. Your job is to figure out what x is. It's right over here all by itself. So aren't we just going to type this in on our calculator? The only way you're going to miss this is if you forget to close that parentheses right there, which is very tempting, easy to do. You can't. You got to remember to close it. So 2 log 5 minus 8. Did you get -6.60? What am I rounding off to? 10,021? It would be a shame to miss that problem. It's so easy. Just type it in. Make sure you close the parentheses. Brendan, dear, you feeling okay today? Do you need to go see the nurse?
No, I'm good.
Okay, then I need you to stay focused. Okay?
Sorry.
Max, you got a pass?
I do not. I was just going to see this up. He didn't give me a pass.
Okay, well, it's not his job to give you one. It's your job to ask for one.
Okay.
Okay?
You
No, I want you to stay here. You're missing class.
Yeah.
And I thought your grade was important to you.
It is.
And this probably isn't the class you want to be missing. All quizzes is, if you said, listen, Coach Peoples took this class, okay? So if you said, hey, Coach, I need to get to Mrs. Ford's class, you know what he'd say? Go.
I agree. I agree.
Do you all have a pass, girls?
Yeah.
What is this?
Let's go look along the. She said she was.
Okay. Anybody, Texas applies to you. Anybody who has a quiz that's not made up has to have it done tomorrow before school. Okay? So anybody that has any of the quizzes from this unit to make up tomorrow before school. Okay? All right, where am I? All right, next equation. Now, this one is not as easy. Look where the x is. Do you see how it's in the middle of the problem hooked to the logarithm? So if you have this situation, the only way to get that x by itself, the only way to figure out what x is to do what? Second log. This time you have the second log. So second log 0.8. And your answer is 6.3096. Remember, anytime, this is going to be important in the next unit we're going to go back to trigonometry a little bit. And if you have sin x equals 0.8, you got a second sign. Anytime the x is hooked to the function, you're going to second whatever, log, tangent, whatever it is. Keep that in mind, don't forget. All right, C, 3 log x equals negative 2.1. Now be careful, Anthony. Yes, the first thing you need to do is divide by 3. So log x equals negative 0.7. Now, how do we figure out what x is if we have log x equals negative 0.7? Same thing, so second log negative 0.7. And I got 0.1995. Everybody good with that? All right, now we have our word problems. So we're going to pay real close attention to what the question is asking and telling me. And figure out what formula I'm going to use. That's step 1. You got to know what formula we're going to use. So let's look at it. You owe $985 on your credit card. The company charges 18.72% interest. How much will your monthly payments? Okay, remember our extraneous root radar? The word payment, what does that automatically mean? If it says payment, we're going to do either FV or PV. So I know I've got it narrowed down. This is an FV or PV problem. I want to pay off the loan, so that's PV. All right. Now, you can do this however you want. Well, first we got to plug the numbers in, but when we start typing, you do whatever you want. But in the end, you have to match my answer exactly, okay? So don't say to me, oh, I'm only off a penny. You're off. There's no need to be off. We should match exactly. That doesn't mean you're totally wrong. It just means you're not going to get total credit. So let's make sure we're getting all this figured out and typed in right. Here we go. 985 is right here. My interest rate is going to go into the problem how? 0.1872. That's exactly right. These payments are monthly, so N is 12. I'm doing it for 4 years, so my exponent is 12 times 4, negative 48. So this is exactly how it should look. Now, I'm not lying to you. Some of you did not do very well on your quiz. And you didn't do very well because you were putting in crazy numbers. These are the numbers that go in. So N is monthly. 12. All right, so everybody okay with all that? All right, now, again, how you do this is completely fine with me, makes no difference whatsoever. I'm going to go ahead and do 0.1872 divided by 12. So this is 0.0156. And this is going to be 1.0156 to the negative 48. I'm going to type this in, but when I do it, I have to be very careful. I can type 1 minus 1.0156 raised to the negative 48, but then I have to hit equals. Don't forget to hit equals, and then divide that by 0.0156. So when you type in your numerator, whatever strategy you're using, you've got to remember hit equals before you hit divided by. Now, I got for this whole mess 33 point something.
Yes.
Okay? Now, you can write down that whole number if you want. It doesn't make any difference. I don't care. I somehow have to get R by itself, though, which means I need to take 985 and divide it by whatever this is. So I choose to do 985 divided by second answer. That way I don't have to write down or type anything in. And your monthly payments are going to be $29.31. Just for fun, it wasn't asked in the problem, but what that means is you borrowed this much, you'll be paying back this much. It's a lot. Credit cards are not good. They're necessary parts of life, it seems, but always pay them off. Pay them off in full every month. Don't use them for credit. All right. If you didn't get this, we're moving on. So stop. Stop. Pause. We're moving on. If you didn't get this, maybe you should come in during Flex tomorrow and we can type it in. Make sure you know what buttons to press. All right, here we go. Number 7. The increase in the length, inches, so Y is going to be inches, of a poison ivy vine can be modeled by this equation, where X is in days. So Y is inches, X is days. Can you tell from the equation if this vine is getting longer or shorter?
It's growing.
It's growing. How do we know it's growing?
Because it's positive.
It's not going to do it positive. It has to do with the fact this number is bigger than 1. So this is increasing because it's bigger than 1. All right, what is the initial length of the vine? How long is the vine at the very beginning of the problem? 1.9 inches. Now, there's 2 ways you can do that. One is you've been paying attention and you know that in problems like this, that's your starting number and this is your ratio. So my starting number is 1.9. The other way you can think about it is at the beginning, the initial value, x is 0, time is 0. If you put a 0 in here, you get 1 times 1.9, okay? So the initial length of the vine is 1.9 inches. What is the length after 8 days? How long is the vine after 8 days? How would we do that? Put in 8 for x. Kids, do not make that hard. X is days. You want 8 days. Put in 8. Use this exact equation. Let x be 8. And the answer is 29.68 inches. When will the plant be 16 inches long? When will the plant be 16 inches long? A bunch of you are scribbling stuff down. What are you writing? How do you do this if you want the plant to be 16 inches long? Yeah, exactly. We put the 16 in for y. The rest of your equation stays exactly the same. You just put the 16 in right here because we want it to be 16 inches long. How do we solve this?
Divide by 1.
I'm going to use logs, but not first. First, I'm going to divide. You must divide first. Now, guaranteed that is not going to be a nice number, but I am not worried about it at all.
421.
It's 8.42, blah, 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 something. I'm not even going to write the whole thing down. You can if you want. I got it right here on my calculator. I'm going to use my second answer button. But you can write it down and type it back in. It doesn't make any difference.
Log.
Now I'll log both sides. And what's going to happen to that x when I do that?
It comes out in front.
It comes out in front of this logarithm right here. So to get x by itself, to figure out what x is, don't I just need to take this guy and divide him by the log of 1.41? Isn't that how I'm going to get my answer? So what you're telling me is I need to take the log of this big ugly decimal and divide it by the log of 1.41. So I'm going to say log second answer, close parentheses, divided by log 1.41. And the answer is 6.20 based. Now, for some reason, some of you are just scared of second answer. Fine. Type in this number, whole thing, and you'll get exactly the same answer. Take the log of that, divided by the log of 1.41, and you'll get 6.20. Your favorite relative deposits $1,212 in an account paying 3% interest compounded monthly, what formula? A equals P, 1 plus R over N to the NT. I completely understand that this relative is saving for your future. But this relative is not making payments. It's a one-time deposit. This is the formula. PV and FV are only for payments. All right. Where do I put the 1212 number? That's P. The interest rate is 0.036. What does compounded monthly tell me? N is 12. And the first question is, how much will you have after 8 years? So your exponent is going to be 96. 12 times 8. Do I need logarithms? Heck no. I only need logarithms when this happens, right? That's just to type in. Just type it in. 1212, parentheses, 1 plus 0.036 divided by 12, close parentheses, raised to the 96. Just type it right in. And you're going to have 1615.82. $1,615.82. If you're not getting that, you're going to come in and see me, right? Or check it out with your buddy next door who's getting them all right. Okay. When will the original investment be tripled? When will the original investment be tripled? Now, are we in the same problem? Yes. So we're going to be using the same setup, but it's going to be a little different now. What's it going to look like? A is going to be 3636 because we've tripled, that's times 3, the original investment, which is still 1212. Interest rate is still 0.036, still compounding monthly. What do I not know? T. So what's my exponent? 12t. Please don't make the exponent just t. The exponent is nt. I know n is 12. I don't know what t is. All right, now what? Divide. Get rid of this. You have to, kids, every time. It's not going to work if you don't. So that works out nicely. So 3 equals, you can go ahead and type that in if you want. What is that? 1 plus 0.036 divided by 12. 1.003 to the 12t. You don't have to do that, but it makes it look a little nicer.
This one. I think you're reading my policy.
Now, why would it do that?
It's like popping on the screen.
No, it's still going. I don't know. See, why do these messages come up all the time? It's still going, but thank you for saying that. Actually, yes, you keep an eye on it because it only holds so many, and I think I forgot to delete, so keep an eye on it. Because it will stop if it gets to the... What? All right, what happens now? What am I going to do? Log both sides? So the log of 3 equals 12t log 1.003. Now what? Divide. divide by log 1.003. Now, I can type in log 3 divided by log 1.003, but this time that is not the answer because that equals 12t. So I need to take that and divide by 12. So it's going to take 30.56 years. It's a lot of years, but I'll tell you guys, the years go fast. Very, very fast. All right, here we go, number 9. You got Jacob dozing off 2 times on the first day of school, 6 times on the second, 18 times on the third, and so on. So we have a geometric sequence. Those of you from Alpha Period last semester know exactly what I'm talking about here. Could have been Solomon, who's dozing off now. How do I set this up? I want to find the 10th day of dozing.
That's the song.
The 10th day. Aren't I looking for a sub 10? 2 times 3 to the 9. So 2 times 3 to the 9. Ooh, 39,366 doses times. How many times will he have dozed off altogether on the 12th day of school? What formula are you using there? The sum. You want to add up the first 12 days to find all together. So you got your formula sheet. It says take the first term minus the first term times the ratio to the 12th over 1 minus the ratio. With this formula, please do the denominator separately. And then you can just type in the numerator. I got -10, big number there. So I'm going to divide that by -2. And I got 511,757 times that he dozed off.
That's not what I
That's not right.
It's 5, 5, 3, 1,
Oh.
4.
You're exactly right, thank you. Somehow I pressed an extra button on there. So 2 minus 2, thank you for having the courage to speak up. So this is a 10 number, but it's a different number. So did you get 531,440?
Yes.
There you go, Tom. Thank you for catching that. I had an extra number somehow in there. Okay? All right, one more. You would love to be a millionaire in 22 years.
Oh yeah.
How much will you need to deposit right now in order to reach your goal if the bank will pay 3.6% interest compounded quarterly? All right, so understand what's going on. Are you going to the bank over and over again? No. You're going down to the bank right now. You're going to hand them a chunk of money. You're going to come back in 22 years and have $1 million. That's the goal, right? So what formula am I going to be using? FV?
Yeah.
Am I?
Yeah.
Tell me why I'm using FV.
For your future.
I'm definitely saving for the future, but what is the criteria for using FV? They gotta be making payments. Am I making payments? No. It says compounded quarterly. What formula am I going to use? A. Compound interest. Guys, I understand completely. I think I've already said this. I understand completely. We're talking about a future value. I get it. The problem is the future value formula only applies if you're making payments. So if the problem said you want to have $1 million in X number of years, every month you're going to go down to the bank and put in $800. What would the interest rate have to be for you to have $1 million after 22 years? Something like that. If you're going down and making payments every month, that's an FD problem. You're not. You're going to walk down and hand them a chunk of money, which is going to be a big chunk, so that you can end up with $1 million at a 3.6% interest rate, compounded quarterly in 22 years. Does the 88 make sense to you? Quarterly for 22 years? Now, this is what you're solving for. Does it make sense to you that we're going to work this out and then divide $1 million by it? So that's what I'm going to do, and that's what you're going to do, and we're going to get the same answer. I told you it was going to be a lot. One more time, make sure I didn't make a mistake. Oh, somebody else get that? Okay.
Be nice and I'll have to wait.
Yeah, I got that twice.
Yes.
So I think that's right. So that's how much we would have to go down and deposit right now, so that you would be a millionaire in 22 years. Okay? Everybody good with that? All right. What we're going to do now then is have a couple of volunteers at the board, and we can use all the boards here, and I'm going to give you a problem, and you're going to give me the answers. So, who are my volunteers? Here's the problem. Horizontal asymptote, we need the y-intercept, and we want to know if it's increasing or decreasing. All right, who can come up and do this? We can have people on both sides. Thank you, Anthony. Anybody want to do that side? Anthony's going to do this side. Same problem, just so we have two people doing it so we can bounce ideas off each other. And then we'll give it a shot over there. All right, well, the rest of you do it at your seats then real quick. Squeeze it in the margin or down at the bottom or something. And let's see how Anthony does with this. Thank you for volunteering, Anthony. By the way, this is a test question. So if you don't know how to do it, if that's why you're not coming up here because you're not confident, you need to get confident. Because Friday it's for a grade. Now it's just for personal pride. He's done already, and I believe he is exactly correct on all fronts. As far as the asymptote goes, remember the asymptote starts out at 0. This equation has a +4 on the end, which has moved the asymptote up 4, so now it's at y equals 4. The y-intercept is the value when you plug in 0. So he put 0 in. This to the 0 is 1 times 3.6 plus 4. That's how he got 7.6. That's your y-intercept. He says it's increasing, and he's right, because the number with the exponent is bigger than 1. Right? Okay. Now, since we have a dearth of volunteers, I am going to say a problem out loud. I'll say it twice, and I want you to write down on your paper the formula that you would use to do it. Okay? So, Yes, you can do it. We'll come up here and do it. You can do it up here. I'm going to say the problem out loud.
You have to write out the whole formula?
And you're going to write down the formula. You don't have to plug in the numbers and stuff. No, write it down. You're going to write down the formula that you would use. Okay, everybody listening?
Here we go, Texas.
All right, here's the problem. Here's the problem. I bought a car and I had to borrow $10,000. So I had to borrow $10,000 for my car. I'm going to make monthly payments to pay off the car. The interest rate is 8%, and I want to pay it off in 5 years. Now, you didn't even need all that last information, because if all you're doing is picking a formula, the minute I said I want to pay off my car with monthly payments, you knew it was what? Write the formula down. Yes. You should know that.
I did know that. That's why I said
You
it.
said, is it?
I didn't say is it. I said I want to be
I want to be able to do that.
This is the PV formula, right? And everybody's got it correct on your paper. In the PV formula, I am making monthly payments. So what is the N? 12. Right? N is how many payments? All right, one more. Thank you, Jack.
That's it.
All right, one more question. You want to sit here for this one?
Sure.
All right, so write your note card.
Yeah. I'm so proud of you.
Here's the question. You know I have these 2 low gram plates. and I want to save money for them so they can go to college when they grow up, because God knows how much it will cost them, right? So I decide that I can save $75 a week to invest in their college fund. How much will I have if the bank gives me, 2% interest, and I do this for 18 years, I save for 18 years? What formula will I be using? I'm using FD. The key word in there was, I'm going to save $75 per week. That means I'm making a weekly installment payment, right? What would the N be in that problem? 52. Because I'm doing it every week, and there are 52 weeks in the year. Burkhart, what are you doing back now? Oh. You know what that means? A detention. A D to the E. All right. Thank you. Did you sit down? Listen.